All right, welcome back to our Chapter 11 video series. I think this is going to be our last installment for Chapter 11, so thanks for your patience. We are going to end Chapter 11 by talking about Le Chatelier's principle and dynamic equilibrium. Le Chatelier's principle is something you're going to hear a lot more about in Gen Chem 2. So let's go back to that idea of equilibrium. Remember when we talked about equilibrium, we said that in our equilibrium, we can take a snapshot of the system in time, and then another snapshot, and it looks like there's been no change. But Le Chatelier says that if something like a disturbance, of course you're thinking Star Wars right now, there's a disturbance in the force, then what happens is the system finds a way to come back to equilibrium. And so when we start talking about equilibrium, we will see equilibrium written by this kind of set of arrows, where we're drawing a pair of arrows that have a half of an arrowhead, one's pointing to the left and one's pointing to the right. And this is trying to indicate that the forward and backward reactions are happening at the same rate. So we can have equilibrium with respect to phases. And so here is kind of a little, equation in a sense for equilibrium between liquid and vapor. So if you start with a liquid, obviously you need to add heat to make that turn into vapor. Imagine you have a pot of water on the stove. If you don't turn on the stove, it's never going to boil, right? So you had to add heat. So if we add heat to the system, what ends up happening is if we push in heat into the system, then it forces more vapor to form. So we get more vapor. If we remove heat from the system, we see the opposite thing happen. We see condensation. So as we take heat out of the system, we get more liquid. So when we talk about the position of equilibrium, what we're just talking about is, the relative amounts of the substances on both sides of the equilibrium. And what you'll hear people say is, if heat's added, it shifts the equilibrium to the vapor side or to the product side or something like this. I always imagine this, and this is going to sound just wild. I always imagine in Le Chatelier's principle, which is this whole idea of, changing something and seeing a result. I always imagine like a little person. And if we kind of look to this next example and we look at, this solid vapor, this sublimation example, in my head, what's happening is if heat is added, I see like a little person just pushing heat into the system, which makes more vapor form. So we get more vapor if we add more heat. And then if heat is removed, what I see is a little person. It's kind of like, what are those dumb crackers that are shaped like people? I see like one of those little people, just like they're just taking the heat and they're like, no way, that's my heat, man. And they take it out of the system. And then what happens is to balance out that disturbance of less heat, your vapor then turns into solid. And so you get more solid. And I forgot to write the word vapor here. So we'll go back in and write that in. So let's ignore this question for a moment and come to some phase diagrams. Phase diagrams are so interesting and they can be just mind-boggling. And the reason that I think phase diagrams are so fascinating is because this is a graphical representation of pressure and temperature changes and how those pressure and temperature changes affect whether you have a solid, liquid, or a gas. So in this phase diagram, let's point out a couple of things. If we're looking at this line here, this is the line where vapor and solid exist at the same time. That's what's so mind-boggling. Like, can you even just imagine vapor and solid existing at the same time? Like, I mean, I guess I can if I took dry ice and put it in one of those dumb glass boxes we talked about earlier, right? They're existing at the same time. But I don't know. It's just wild. And so then for the BD line, this is where you get liquid and gas at the same time. And if we look at this line here, that is where you have solid and liquid at the same time. So then the other two locations that are just really wild is the critical point, which is over here. So that point is where the density of liquid and the density of vapor are the same. What that means is there is no distinct difference between liquid and vapor. I am going to try and remember to show you a YouTube video of this by, what's his name? Oh, he's this crazy old guy who looks like Einstein, where he did an experiment of it. It's really fascinating. And then the triple point is the other really fascinating point, and that's here. And that's where all three phases exist at the same time. So let's talk about the types of questions that you might see with a phase diagram on the exam, because you can guarantee you're going to see some. So let's see if I wrote any of those questions down here. Oh, yes, I did. Okay. So here I've got a clean phase diagram and there's a couple of questions. So the first one, what happens if the pressure is increased while on the solid liquid line? All right, so just pick a point on the solid liquid line. Let's pick here. And we're increasing the pressure. So the pressure is on the y-axis. So we are keeping the temperature the same. We're increasing the pressure. And we see that we move from a solid to a liquid. So we see that this turns into a liquid. So what is the word from going from a solid to liquid? Like if I gave you a multiple choice question and didn't have turns into a liquid as an option and actually gave you the chemistry words, would you be able to answer it? Because if you can't, make sure you go back and you look at that those phase change words that we looked at the beginning of our last video. Okay, what happens if the pressure is decreased when on the liquid gas line? All right, so let's pick a spot on the liquid gas line, decrease the pressure. We see our liquid turns into a gas. Again, what's the chemistry word for that? Do you remember? Well, if not, go look it up. All right. Let's more specific examples now. What happens if water at -20 and 215 torr, okay, so that's here, is heated to 50 degrees at constant pressure? Okay, so that means we didn't change the pressure. We're going to go to 50 degrees Celsius. All right, so we see we turn from a solid to a gas. Do you remember what that word is? It's one of my favorite. We see sublimation occur. And so on the exam, I'd probably reword this. What I'd probably say is, what phase change would you expect if water at -20 degrees and blah, 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 and the rest of it, right? So that I could say things like sublimation, deposition, and condensation, vaporization. And then you would choose sublimation. All right, how about this one? What phase is water at 330 torr and 50 degrees Celsius? So let's find our 330, let's find our 50 degrees Celsius, and here it is in the liquid phase. All right, let's see if we got any more questions down here. Oh yes, I love this question. Okay, when you look at this question, you're going to say, oh, but it's not listed as solid, liquid, and gas on there. You need to expect that for the ACS exam. They are not necessarily going to come through and say solid, liquid, gas. That's going to be your job. And so this is going to seem kind of silly, but what I always imagine is this part kind of makes a cup. And where the cup is your liquid. Your solids to the left, your gases underneath. And so starting at point A, which is here, keeping pressure constant, but increasing the temperature will give rise to what phase change? So keeping pressure constant, give rise, and temperature is increasing. So you go from solid to liquid. So chemistry word for solid to liquid, melting or fusion. And if you're looking at it and you're saying, wait, but if I kept going, I'd go liquid to gas. When I write the exam, I'm going to be a lot more specific. I'm going to say something like, what's the first phase transition that, you would encounter? And that'll be better. So we will practice some more of these phase diagram questions when we get to class. And we will leave our discussion of solids and body-centered cubic and simple cubic and whatnot for class as well. Thank you for watching.